Hey guys, so today you and I are going to talk about simplicity, so let's get into it. So the question in question was, hi Frederick, should simplicity of code always be prioritized over optimizations that result in complex code? It depends. It depends on whether or not the complexity is warranted or not. That's I would say, the main thing. Complexity is a very difficult thing, and simplicity is even more difficult because what seems simple is very subjective. And so what I usually try to preach is that well, you might have heard me say this term before, the solution needs to stand in proportion to the problem. That's the thing that is very important. And basically the idea behind that is that like a analogy that I've used in the past is, if you have a problem with ants and an anthill, for example, you can remove that with an atom bomb, but it might not be an appropriate response to the issue you're dealing with. Or you can water a plant with a fire hose, but it's also probably not the thing you want. And so when you're dealing with simple code, or when you're trying to simplify your code, that is actually the same sort of deal, because the thing that I can see sometimes is that what you consider to be simple is, as I've said, it's actually very subjective what you feel is simple. A classic one is that you have some people who feel like high levels of abstraction. Well, that's simple, right? There are people who love writing almost DSL-like systems where you get it into your head that the less code you have to read at any given moment, the better, like the less lines of code that you're dealing with, and so they invent a DSL. Now the problem is that the people who feel as if they want to understand what's actually going on, well, now they have to learn your programming language, okay, because a DSL is basically, it becomes a second programming language. So now they have to learn your way of doing things, because your abstractions are your own. They make sense to you, but it may not make so much sense to the next person. And then what later happens is that the complexity of the code evolves into such a point where your DSL starts to make less and less sense over time, because your abstractions aren't accommodating the growing complexity of the problem that you are dealing with. And so now you have a DSL that almost becomes, either it becomes unused, or it becomes a hacky type of weird thing that doesn't really, like, you sort of start, it becomes almost the new bottom layer of doing coding within your code base. So that's a problem. That's a pretty big problem. And then you have people who think in terms of frameworks, where you create, this is a classic one where I see it all the time. It wasn't all that long I dealt with it. You have a person who identifies that a form has a certain amount of fields, and that form is used in two places, exactly two places, and these two forms have commonalities between them. So what does the person do? Well, the person goes and designs a form builder, and then they realize that, wow, you know what? I can create a function that generates these two forms. I never have to recreate this form ever again. And so they create this super generic solution where you basically just plug in the fields that you want to generate within the form and the types and so forth, basically creating a configuration system for building said form. And said and done, that's now done. And they have this magic little function that you just push in a bunch of configurations that you need to know about, of course, and then it just automatically generates the form, so you don't have to write that code yourself. And then I come along later on and I see that, well, now I have a story specification that forces me to change the overall structure of this form. It's basically not going to work exactly this way anymore. And it takes me tons of time to do, because there's of course no documentation, no thoughts into designs of APIs or anything like that. Even though this is simpler, objectively it's simpler, for the person at the very least who implemented it, but the person hasn't thought about the simplicity of consuming this, learning how to actually use it, etc., etc. So it's actually not simpler. It takes me a ton of time, and at the end of it, I basically have to throw away the whole thing because it no longer fits the intended use case of the feature. So is that simpler? Well, then the next person might come along and say that, well, clearly we should just not do all these advanced abstractions, or we should prioritize just writing code as is. And then you see people writing files with hundreds and hundreds and hundreds of lines of code that is fairly enormous to the average person, overwhelming even. You might have like imperative programmers who just basically write everything in one gigantic super function that does absolutely everything. And now you have a different problem because now the overall size of the code and the amount of complexity one has to deal with, there's no like segmenting of anything, is so gigantic that for someone who's going to read that code, it's actually really difficult to figure out what's going on. So this idea of creating an optimized solution or a simple one is actually very, very difficult. And I argue that the people who do this well are usually the people who understand other software developers, DevX as we call it. You basically figure out which problem that you're dealing with, and usually how various software developers deal with this sort of issue, or how they are accustomed to handling a certain piece of complexity or so forth. You're basically trying to figure out, it's almost a bit like product development in a sense. You're trying to figure out, your customer is the software developer, you're trying to figure out which solution will be appropriate here, because in some cases a very complicated, like a highly optimized solution is necessary, because there's simply the thing that you want to achieve is not possible to simplify any further. And again, I'll take a simple one where if you wanted to, as an example, figure out how to write a compiler, or you wanted to figure out how to structure a bundler in JavaScript or something like that. Like, these are complicated products, and there's really very little you can do in terms of changing the inherent complexity to that problem. But you can simplify it. And so what they do is that they create a library, an interface on top of all of that complexity that exposes the necessary functionalities so that the other developers can consume it in a ready fashion. That's the thing that you can do. But there's never a situation where, like, we're speaking about bundlers, like, to this day I have never talked to a front-end developer. Almost no, on average I've never talked to a front-end developer who can tell me what Webpack actually does, how it works, how to set it up from scratch. Practically every single one, and even all the way up to the quote-unquote seniors, don't actually know how to do it, or they can't explain it. And so that's a very sophisticated tool, and the only reason why it's usable is because, and even at that level, like, we even have tools upon that, like we have others, like other systems. It's the same thing for the Java people. Like, Ant used to be the thing, right? And then Maven becomes the thing, and then we have Gradle and so forth. Like, you create versions of simplifications on top of this very complicated thing that you're trying to do, right? And so that is the way that I suggest that you think about this. Simplicity is subjective, and optimization is subjective, and it's really just it's a trade situation. It's a trading type of problem. You can't just say you should always do one or you should always do the others. That's what a seller does. A real master understands that the goal is to meet some type of success criteria, and it's a success criteria is that you have to meet certain optimization requirements. Like, you have to write code that works in a certain way, because otherwise the results are not going to be there. Then you have to optimize, but you should always try to make your solution as simple as possible. But sometimes you simply can't simplify it any more than is at that stage, so you try to do the best that you can. At the same time, your idea of what's simple is very subjective, and the people who usually succeed in creating quote-unquote simple solutions, look at library authors and things like that, they actually design their quote-unquote simple solution with the intention of it being consumed by other people. So if your consumer, your customer, other developers feel that this is fairly straightforward and simple to follow, then you're on the right track. So what I want you to take away from this is that there is no way to say if simple code or optimized code is the way to go, because it depends on the problem. Sometimes there's what I like to call inherent complexity. In other words, you're dealing with a problem that is so complicated that you can't really simplify it anymore. You can make it as simple as possible, but the problem is what the problem is. And so what you should always attempt to do is to make your solution stand in proportion to the problem that you're dealing with. As an example, with my little form thing I was talking about, I remade that form in less than 30 minutes, something like that. Or it took me several days of just debugging and so forth to figure out how everything actually fit together in this massive form builder that was dealing with 2 forms. And it turns out that the new requirements made it so that the one form could stay sort of the way it did, and the form that I created, which took a fraction of the time, now fits the use case, and it's I argue a simpler solution. And so that is an example of where someone tried to simplify something but actually just made it a lot more complicated than it was needed to be. It's over-engineering. And so that balancing act between simple and complex is a very subjective thing, and that's why I tell you, try to always think in those terms. If you need something to work in a certain way, if it's a hard requirement of optimization, then you have to implement it as simply. I can make it as simple as possible, but it still has to meet those criteria. And when you're simplifying something, make damn sure that you're not actually complicating it for everybody else and just really simplifying it for you. Have a great day.